Okay, welcome back to part 3 of the weathering in soil notes. Let's go through this quickly. Rain picks up carbon dioxide from the atmosphere. This rain then becomes slightly acidic. It goes down through the soil where it can leach out materials. It also picks up more carbon dioxide, as I told you, from the soil because the soil atmosphere or soil air is even more acidic or more carbon dioxide rich. Now, another weird case of weathering. Sometimes you can have weathering from below. When you have gases and warm waters coming up through the earth, if they come up through a granite, you can create what are called these granite tores. If you go up toward Payson on the Beeline Highway, you're going to go through a lot of stuff like this. And you're going to see spheroidal weathering up there too. One more cool example of chemical weathering. Kimberlite pipes. These are extremely, how do we call them, violent eruptions that come from way down in the mantle. They're very rare. But in South Africa, there have been a few of these, and they shot up, they froze, solidified in the Earth's crust, and we are now weathering down back to them. What happens is the gray stuff wears out first, the surface wears out first, and then all the diamonds are kind of concentrated here. Okay, so we picked those up and we're now digging down through this kimberlite formation, an old lava, what would we call it, neck essentially, volcanic neck, and mining the diamonds in there. When we mine and we leave lots of metals out, even if these are toxic metals, they will oxidize and change color. There are all over the West bitter springs, sulfur springs, things like that. There's a reason they're called bitter and sulfur, and you see crossbones next to them. These often are quite poisonous. If you don't see a lot of stuff living around the edge of the water, I'd leave it alone. Now, if you have a rock that you really love and you want it to last for a long time, where would you put it to make it last for the longest time possible? Sorry. Crazy answer, Antarctica. You don't want it ever to freeze and then thaw. You don't want it to be exposed to a lot of precipitation. You don't want big changes in temperature. So the best thing is simply to put it in a deep freeze. Crazy, I know. Now soil. Where would we be without soil? Well, we wouldn't be. If you dig down through the ground, you're going to see this kind of stuff. Not everywhere, but you're going to find what's called the topsoil, which is mostly organic material, lots of microbes, lots of bacteria, and detritus, old leaves and plants and stuff like that. Then you're going to get down to the subsoil. Then you're going to get down to sea horizon. Then you're going to get down to weathered bedrock. There's a better drawing of it coming up. Now, if you want to watch soil form, these people have gathered here to watch soil form. It's not a good thing. Soil typically forms, you can figure out about 1 inch per century all the way up to 1 inch per 1,000 years. In other words, it's very slow. When we farm on soil, we typically erode it 10 to 100 times faster than that. So is soil renewable? Not the way we're treating it. Now, soils can be residual. If these soils formed in place, we would say they're residual. If they are brought in here by a river or by wind, we say that they are transported. And soil can be classified according to its composition. Is it sandy, silty, clayey, and yeah, that really is a word, or loamy, which is a mixture of sand, silt, and clay. Here we go. Top horizon is called the O horizon. In Arizona, you're not going to see a lot of this. The A horizon, lots of organic material. Again, in the Phoenix area, you're not going to see this. Up in the forest of Arizona, you will. Down here, this is what we have more of, and then down here is the weathered bedrock. This is a generalization picture. It's not very accurate. This is a little bit more accurate. Here's your A, and this is typical farm soil, something you might see in Missouri. You get the idea. This is bedrock down here. This is the weathered bedrock. It's the mixture of bedrock and soil. Now, when water comes down through the ground, sometimes it dissolves the calcium that is in the rocks up above. That calcium goes down with the water, and then when the water turns around and begins to evaporate, it leaves a layer of calcium. This is called caliche in the Southwest, and it is really hard to dig through. Some people call it hardpan. If there is mineral-rich water going through the ground and that water is being lifted up through evaporation, you can also form caliche layers that way. This is a wash in the Phoenix Mountains just off 7th Street and Thunderbird. All this white stuff, believe it or not, this black basalt has calcium in it. When the rain comes down across here, it leaches out the calcium and then it gets deposited underneath the surface. If you dig down underneath this black rock, you're going to see this calcium. It's good for our bones, but it makes it really hard to dig in. And if you ever go through a stream bed, you'll see this calcium kind of lining a stream bed in the Southwest. Here's what I'm talking about. This caliche has just covered everything, essentially making a temporary conglomerate rock. Now, soils in the Southwest usually aren't very thick. This is out on, I think, about 12th Street or 7th Street, 7th Avenue, sorry, south of Carefree Highway. I was out biking there. Take a look. Here is the topsoil, and then the rest of the horizons are right in there. We immediately transition into bedrock. Where has all the soil that was here gone? It's gone way down to the bottom. Soil doesn't hang out on hills very often. By the way, if you go out to Scottsdale Road and Pinnacle Peak, they are digging pillars for a really big bridge. They've gone down 20 feet in that area because it's flat and they haven't hit bedrock yet. So soil depth varies widely depending on the location. Now, what will affect soil formation? One, your parent material. For example, in Hawaii, whatever soil you get has to come from volcanic rock. That's all you have. If you are in the northern part of Arizona, you're going to end up with a really clay soil because the Colorado Plateau has a lot of clays and sands and silts. And if you live up there, you're going to be dusting a lot. Just get used to it. If you're going to live out by the McDowell Mountains in the northeast part of Phoenix, Scottsdale, you're going to have a lot of sand simply because it's granite breaking down. Climate will affect soil formation too. By the way, on a slope, thinner soil. Down below, thicker soil. On top of the mountain, you can have thin soil unless it's steep. If you have more critters, you have more organic material. By the way, we call a very thin soil a young soil, and a mature soil is a really thick soil. Let's see. Soil scientists go a little bit crazy. They like to classify soil types. Alpha sol, andesol, iridesol. By the way, this is where we are. And I would zoom in on this, but it's not zoomable. Here are more of those terms we don't care. But here are some general classifications of soil around the United States. Different soils tend to be good for different things. For example, if you're trying to build a house on a clay soil, don't. At least not directly on it. You're going to have to cover it with something else first. Here's another little bit more detailed type of soil map of the United States. Now the Australians, they get some crazy words for their soils. Karakata. You guys can pronounce these. I'm not going to. Soil erosion is important. We talk about nuclear bombs. One of the things that's probably affecting all the world more is soil erosion. Without soil, we're not going to have food, and we don't seem to understand it. Big corporate farms go in, they start farming. They really don't care about the soil because they will just pump in more fertilizers. That's going to work only so long. It's like steroids for the soil. It's a nice quote here from the Dalai Lama. He understands the need of humans for soil. In fact, all life for soil. There is splash erosion that goes on with soil. One little raindrop comes down and hits the soil, spreads it out. Not a big deal, but when you have a few hundred million raindrops doing it, you end up with sheet erosion, where entire layers of soil can be eroded. In one big rainstorm, you can lose a century's worth of soil. You have several rainstorms a year, you can lose several centuries of soil formation. And if you're not careful, you can end up gullying. Now, once you've created a gully, then the water will run down the gully, and you actually lower your water table. This happens often in the Southwest with overgrazing. If you start taking your four-wheelers, your quads everywhere, the same thing can happen. Be careful where you drive. And deforestation is a big problem. This is down in Indonesia. I believe this is Borneo, which is now called Myanmar. This is it in 1950. There was the area that was deforested. 1985, 2000, 2005, 2010, 2020 is what's predicted. Where's all this timber going? Remember all that cheap stuff you buy at Home Depot or Costco or Target or Kmart, Walmart? It's made out of wood here. Again, corporations going in, cutting it down. Oh well, we're making money, and money really is much more important than keeping the soil, right? I mean, tree roots will hold soil back, but that's not a big deal, is it? This is Madagascar. This was Papua New Guinea. This was it back in 1900. 15 years later, all this area has been deforested. It's also happened in the United States. We've covered this in a previous film, but this is the Dust Bowl in the 1930s in the United States. Soils that took over 10 millennia to form are gone in 10 years. This is Spearman, Texas, 1935. And when we run that soil into the ocean through the rivers, it has so many nutrients in it. You have algal blooms in the water, then those algae die, and then you create dead zones. It's kind of crazy, but we are fertilizing ourselves to death. This is what's going on in the Gulf down toward New Orleans. All the runoff from the farms creating algal blooms and then dead zones. Here is a red tide. Not a red tide, a dead zone, my bad, where all this stuff is dying. By the way, this is on the bottom of the sea, the lack of oxygen from the rotting stuff. And one last thought. Rainforest soils are being deforested because we can get to the bauxite under them and get to the aluminum-rich rock. Take the aluminum out. It's really a good idea to recycle your aluminum cans because, strangely enough, recycling your aluminum can save the rainforest. And I think that's it. Thank you.